channel. Today we are diving into one of the most powerful tools in engineering design, the piping and instrumentation diagram. I often say if you can read a P&ID, you can visualize the entire plant even before a single piece of equipment is installed. Across every phase of project from concept, design, detail engineering to commissioning, operation and maintenance. The one document that unites all discipline is the P&ID. It is not just a schematic, it's a technical blueprint of a process intent, an integrated view of instrumentation and control philosophy, and a critical tool for troubleshooting, safety analysis, and plant modification. In this video, I will walk you through how to read a P&ID practically. We will take a practical approach to understanding how to read and interpret a P&ID, not merely by decoding symbols and line, but by uncovering its underlying logic, what it conveys, what it implies, and how it seamlessly connects process control, instrumentation, and other disciplines. Okay, so let's start with session. What you will learn in this session. So basic difference between the PFD, a process flow diagram, and piping and instrumentation diagram. The importance of process and instrumentation diagram. A layer of information provided in the P&ID. I'll also walk you through key elements, naming, legends, and symbols used in the P&ID. At the end, we will learn how to read the P&ID. Uh, what is P&ID? So P&ID stands for Piping and Instrumentation Diagram, a schematic diagram that shows how piping, a mechanical equipment, the instrument connect to form a functional process system or the unit. All these elements are represented using the various piping and instrumentation diagram symbols as per ISA 5.1 or maybe your company tagging and symbol philosophy. What does P&ID typically include? So typical P&ID will have a plant equipment like vessels, heat exchangers, pump, compressor, turbines, and many more. It will have pipelines and the flow direction, tie-ins between the packages and between the units, the battery limits. It will also have process instruments and valves. It will have information about alarms, interlocks, and process control loop. Okay, so let's look at the PFD. So PFD is a process flow diagram, a simplified overview of a process. A process flow diagram shows a main process flow scheme and major equipment. So it will have major interconnection between the equipment and the process flow, like big pipelines, how your process is flowing from your feed to the final product. It is the first document to start with. Uh, Now we are moving to P&ID, piping and instrumentation diagram. So it's the more complex and more detailed version of the PFD. So P&ID provides a detailed graphical representation of an actual process system, including piping, equipment, valves, measurement instruments, and other components within the system. It will have nodes, it will have process safety related information, it will have process control loops, and it will make a very detailed process flow where you can visualize how your actual process is going to behave, look like. Now, okay, so let's look at the importance of the P&ID. So P&ID is one of the critical and essential document to run any facility safely and reliably. So P&ID forms the foundation for designing facility, the operating facilities, and controlling facility in a safe and reliable manner. It helps us to plan safe shutdown. It gives us each and every detailed information required to operate the plant. PNID provides a detailed information on critical components and plant process layout within the system or within the unit, as well as it will give us a detailed overview of the actual process happening in the real-time plant. P&IDs are essential for evaluations like HAZOP, model reviews, process safety management throughout the facility life cycle. P&IDs are very important for maintaining a process operation. It becomes a guide for maintenance and troubleshooting during the abnormal conditions or during the any breakdown. P&ID act as a universal language enabling all stakeholders to discuss and coordinate plant operation effectively. P&IDs are foundational material for training. You can train operator, you can train engineers, maintenance engineers, design engineers with the help of the P&ID. Let's deep dive into a P&ID. So P&IDs are well organized. If you look at any piping and instrumentation diagram, you will see there is a meaningful layer of information. So during this session, I will walk you through how to interpret information available on the P&ID and how to identify what layer of information you are extracting from the P&ID. So as per my experience and as per my understanding, I have understood there are 5 layers of informations are available in any of the P&ID. So start with the layer 1, which is your process piping and lines. So this particular layer focuses on the physical pathway for material flow or the fluid flow. So we'll see any P&ID, you'll see the process piping and lines, and you can clearly navigate your material or the energy or the process flow from start to end. The second layer is about mechanical equipment. This layer identifies all the major pieces of static and rotating equipment used in the process. So you can see the heat exchanger, you can see the vessels, you can see the pumps, you can see the compressors. So that's the layer 2 information. Then you'll go further, you'll find a layer 3 information, which is your valves and the components. So this layer details all the components used to control or isolate your flow or the process. It may be a manual valve, it may have control valves or valves with the actuator, flanges. So all these are the layer 3 information. Further, if we deep dive, we'll have layer 4. So layer 4 is instrumentation and control. This is a critical layer that illustrates how the process is monitored and being controlled throughout the process life cycle. And the fifth layer is very important. It's operational and the safety information. So if you look at the P&ID, on the right side of the P&ID or maybe on top of the P&ID, this particular layer includes a supplementary information, which is very essential for the plant safety as well as efficient operation. It may be in form of the notes, it may be in form of the some guidelines. So all these 5 layers are well organized in any particular P&ID. And if you can look at this particular drawing, you can easily navigate what are these 5 layers. So you can see layer 1 on the pipeline, which has the line and the process flow. Your layer 2, which is your main equipment. So you can see here it's a heat exchanger. Your layer 3, which is your valves, the manual bypass valve you can see here. Your layer 4, the instrumentation and controls, and your layer 5, which is providing you information about your design parameters as well as a note associated with this particular P&ID, how it is organized within the P&ID. Now I will walk you through how to leverage this information to effectively interpret and read the P&ID. So let's talk about the layer 1, process piping and the lines. So if you look at layer 1, process piping and lines, it will give you information about pipe routing and flow direction. So how your pipe, taking feed from one place and processing it and going to the next equipment. So you can easily navigate that information within the P&ID. You can also navigate line numbering and identification, the pipe class and material specification based on this layer. I'll walk you through that how to decode the line numbering in the next slide. You can also get the information about your pipe size, what is your line size throughout the unit, what are the different line or pipe you are using in your plant. You can easily navigate through layer 1. You can also have information about insulation and heat tracing requirement for that particular process and available at that particular pipeline. It will have information about all the vents or drains, a sampling line, and other special fitting if it is used. So if you look at process piping and line, there are 3 major pipeline associated with the process. So you can easily interpret it from the P&ID. So dark black line represent your main pipeline, which is actually carrying your feed to the processing equipment and then taking it further to next unit or the system. There will be cases where you might have underground pipeline. So you can identify those pipeline if it is a dotted dash pipeline. There will be multiple minor lines, including vents, purge, instrument line. Those will be lighter than your main pipeline. If you see any typical pipeline, it will have numbering. And how this typical line numbering works. So I have provided a typical example here. So any particular line number, if you read, it starts with the line service. So your first will be your line service. Either it is hydrocarbon, it is nitrogen, it is air. So that first letter will indicate about the your line service. The second letter is about your unit number or system number. So for example, it's a utility, it's LNG, it is FCC. So that particular unit number will help you to identify what is this particular system. The next unit will help you with the line size. So either a 6-inch line, it is a 12-inch line, or it's a 1-inch line. You can identify from the third letter. You can also have information about the pipe schedule. So you can easily get that information from the line numbering. Further, if you go further, you will have your material class. So this material class will help you to identify what is the material class for that pipe, and you can directly cross-check or correlate it with your piping material specification. The last letter will help you to understand either it is required any specific type of the insulation. So that last letter will help you with the insulation requirement of that pipeline. This is all about pipeline. And if we move further, we'll talk about the layer 2. So layer 2, which is your mechanical equipment, all your rotating as well as static equipment. So if you go to layer 2, the equipment symbols. So normally you will see in any particular P&ID, you will have equipment symbols like pumps, vessels, heat exchangers, columns, and you can find all this information from your legend sheet. I'll talk about that further in our discussion. Uh, then you'll have equipment names and unique tag numbers. So every equipment in the P&ID has unique name and the tag number, because that will help you to address the equipment as well as to maintain asset register in your plant. Every P&ID will also indicate a basic design data. So if you go to top of the P&ID, there will be a equipment name, and it will have a basic design data like a capacity, a design pressure, design temperature, and sometimes some additional information for the specific case. It will also have interface for the component delivered by the vendor. So you can easily navigate or tie-in available between your core plant facility as well as a package supplied by the vendor. So you can easily have all this information on the layer 2. Now how to navigate or how to identify the equipment. So uh, when you go to the legend sheet, you will see the equipment symbols. So I have taken some of the symbols here. So you can see the vessels, the pumps, and the heat exchangers. Same way, we'll have multiple symbols as per ISA 5.1 or as per your plant philosophy. Yeah, you can easily navigate through that. How to identify equipment numbering? So if you go to any particular typical P&ID, it will have a unique number for each and every equipment. So um, here are the how to decode the equipment number. So if you see again here, your first two digit will be your first 2 or 3 digit will be your unit or system number. Then you will have your equipment. It may be a pump, it may be a compressor or heat exchanger. So that will be your second uh, uh, later. And then you will have your serial number. So in plant you will have multiple equipment. For example, if you have 3 heat exchangers, so and those 3 exchangers are a part of the unit or system 11, you will have 1101, 1102, 1103 subsequently. And then you have suffix. So sometime you may have redundant equipment like pump A, pump B. So in that case, you will have provision to provide a suffix to each every equipment and give them unique identity to easily identify and navigate. Now let's talk about the layer 3. So we have seen the layer 1, the main process pipelines, and then the layer 2, a major mechanical equipment, rotating as well as the static. So layer 3 will have a walls and component which is required to control and isolate process flow to maintain your facility safe and reliable. So if you see the layer 3 information, you will typically see the different type of the walls. For example, gate wall, ball wall, check wall, globe wall, and safety and relief valves. You will also see wall identification and tag numbers on each component to identify the uniqueness of that particular device. There are certain valves with the actuator, so you can also have the information about the actuator type for the automated valves. And you'll have information about flanges, reducers, strainers, and the spectacle blinds wherever required. For specifically actuator valves, you will see there is additional information. For example, fail close, fail open, fail last position. So it will be indicated under the valve. Same way for the many manual valves, you will also see car seal open, car seal close, additional information for a specific scenario where it is required. I have tried to put one of the on-off valve on the screen. So you can see there is a HV1982 which is on-off valve with the actuator, and this particular actuator is actuated by the solenoid HY1982, and the command is coming from the DCS. We'll discuss more about the control side in the next going slide. Uh, Now, how to identify a type of the wall or the more information about the wall. So if you look at this particular diagram, and if you see the P&ID, the walls in the P&ID will have a basic coding. For example, if you see a manual wall size written here, you can see there is a wall specs written there, and then the wall tag number. So if you refer to that particular wall specs, you can identify what is the class of wall, what type of the wall it is there any specific requirement associated with this particular wall, what are the body materials and the end connection requirement. So by looking at one single image and then referring to the wall specification, you can get tons of information to understand the properties and characteristic of that particular wall. That's the power of process and instrumentation diagram. Moving further, so we have seen the layer 1, all the pipeline, layer 2, all the equipment. Now we are moving to the instrumentation and control, which is very near and dear to my heart, being an instrumentation and controls engineer. So when you move to layer 2, layer 4, so this layer 4 is specifically talks about the instrumentation symbols and tag identifiers. For example, pressure transmitter, flow transmitter, the level transmitter, etc. It will also give you information about a location of instrument, where that particular instrument is located. Either it's a field mounted, it's in control room, or it is accessible, or it is non-accessible. You can easily identify it by looking at the symbols provided in the P&ID. It will also help you to understand type of the signal, what type of signal is associated with that particular instrument, for example, electrical, pneumatic, or software data link. And then it will also help you to understand a control and shutdown scheme for that particular instrumentation. It will also include information about the interlocks, alarms, and the safety requirement associated with that particular instrumentation. So if we further get into detail of the instrumentation symbol and tag identifier, so if you refer any particular P&ID, you will see instrumentation symbol. So one of the example I have provided here of the flow transmitter with the orifice. So you can see that how to decode this particular flow transmitter. So first 2 digit or 3 digit will be your unit number or system number. The second will be your instrument type. So if it is a flow transmitter, it will be a flow FT. If it is a flow indicator, it will be FI. If it is a PT, a pressure transmitter, temperature transmitter, and then you will have loop number for which particular loop this instrument is attached to, and then you have suffix. So for example, if you have more than one instrument for the same purpose, you can have A, B, C. For example, one out of two configurations, you have FT 189898A, FT 1898B. Hope this helps. Okay. Now, so further if we move ahead, so how to identify where this particular instrument is located. So if you see any particular P&ID symbol, it will have this these symbols attached to each and every instrument. So there are three different category. So if you see a round without line, it indicates that your instrument is located in the field. If you see instrument with the solid line in the center, it means this particular instrument is located in the control room, okay, and accessible to the operator. If you see, there is a line, dashed line in the circle. It means the instrument is mounted out of the side. Okay, it is not accessible to the operator. So that indicates your dotted line in center. How to understand if these particular instruments are connected to DCS or control system or not. So if you see below, there are shared display, shared control in DCS. So the first symbol indicates that your particular signal is in the control system, control room. Your second one without line indicates that it is in the plant, and then third one, it is not accessible by the operator. So if we go back and see here, so there are discrete instrument, there are shared display instrument, and there are distributed control system as well as your interlock diagram. So any particular symbol with the diagonal or the diamond, it indicates that that particular instruments are associated with a particular interlock in the plant. Let's talk about the type of the signals associated with the field instrument and valves. So if you see any P&ID, you will see there are lines around your instruments and the walls. So those lines have some significance. So you can easily interpret by looking at this slide. There are 6 different types of the signals which are mostly associated with the instrumentation. Like you will have pneumatic signals, you will have electrical signals or electronic signals, you will have hydraulic signals, you may have electromagnetic or sonic or fiber optic signals, guided and same way unguided, and then you have various data communications flowing here and there in the instrumentation. So these are the very helpful lines which we need to remember. So whenever we are interpreting the any particular P&ID, this is going to be a very helpful for us. Uh, so let me walk you through the one of the control and shutdown scheme, which includes the interlocks as well as safety requirement, and you will see this type of the close control loops several time in your P&ID. So I thought this is a good platform to share with you how to read this particular control and shutdown scheme. So if you see here, there are two driving factor. One is your flow transmitter FT123, which is installed in the field, which is sending electrical signal to your FIC 123. Further, this FIC also receiving set point from the TIC, and this particular TIC receives a signal from TT123. So you have your temperature transmitter sending temperature signal to your TIC, where it calculates a set point and then it sends through the data link to the FIC, and FIC will send the analog output or electrical signal to the TY, and then further TY will convert that signal into the pneumatic signal and giving it to actuator, so valve will be operated. In addition to this control process control loop, you can see also YIC 123, which is control or interlock from the PLC. So there is a shutdown valve or isolation valve, which is directly receiving interlock from the PIC. Okay, so you have PLC. So you have in this one particular diagram, you can see the process control loop, you can see the interlock loop. Now, moving to layer number 5. So the layer number 5 is very important because this won't be very visible on your main sheet, but if you go to the left side of the section of the P&ID, you will find a lot of additional information, and on the piping also there will be a lot of information. So for example, it will help you with the operational and safety information. For example, flow direction of your media or service, a permanent startup and flush line, the safety and regulatory requirements, if any, associated with that particular process, interconnection references to other P&IDs. So if you see left side and the right side, you will see the lines, which will help you to understand from where this particular line is coming and from where this line is going next to the system. And there will be nodes and hold points for clarity, so you can easily understand what are the nodes or what are the specific requirement associated with that particular uh, equipment or the instrument. So layer 5 is essentially important, uh, and we have to look into detail to understand the importance of that particular uh, equipment we have seen. So we have seen how this all five layers of informations are organized into P&ID. Now the next is very important. So how we can leverage all these five layers of information and easily interpret a P&ID. So I'll be walking you through how to read a P&ID in practical. So we have seen all the layers of all the five layers of information, and I'm sure that you would have got idea how to interpret the line numbers, how to interpret the equipment numbers, how to interpret the particular tag and its properties, the different type of the instrument signal lines, and then the process and the safety control loops, and how to look into the process and safety information to understand entire process times, and then the uh, battery limits and all this information. So now let's quickly walk through how to read P&ID practically. If you got the P&ID in your hand, how are you going to start it? So what I will suggest is very easy and very simple. First, keep all this layer of information in your mind and look around the P&ID and see that where is the layer 1, layer 2, layer 3, layer 4, layer 5, and how you're gonna leverage those knowledge while actually interpreting your P&ID. So the first step, get familiar with the legends and abbreviation provided. So if you go to any particular P&ID, try to find out where is the legend sheet and abbreviation sheet. Get that sheet, just go through it, try to understand what are the different legends being used and what are the abbreviations for the use tagging and the naming philosophy. Once you are good with the legends and the abbreviation, try to decode your line numbering, tagging, and naming philosophy to understand more depth about the system. Uh, I will also encourage to read a PFD to get familiar with the unit and system in the plant, because once you have PFD in your hand, you can easily navigate what are the different or the big units and system you have in your plant. And then you have legend sheet, you have numbering and naming philosophy being already read. um, then you can start with your first unit or system. So let's say if you are reading the feed system, okay, identify what are the major equipment or unit system associated with that feed system. What are the strainers, heat exchangers, or any other purifier unit. Just go through that, and then start from the process flow, from where you are getting your feed. What are the different equipments? What are the fluids lines? How it is passing to the equipment, and how it is looped around the system. Once you are familiar with the major equipment and flow lines, let's look at the instrument and automated valves or the manual valves. Um, Okay. So now once you're comfortable identifying your process flow and major equipment, maybe you can focus your attention towards the instrumentation valves. So try to locate the instruments and the automated valves. Go through the tagging and naming philosophy to understand what type of the instrument it is and what are the loops and how it is driving. So once you have located instrument and the valves, you can further see that the type of the valve, and then the what utilities associated with that valve, like maybe pneumatic, electrical, and then you can check the power supplies and the air associated with that particular instrument or valve. Further, you can check also it's a fail safe, um, fail safe position, maybe fail close, fail open, uh, fail in last position. You can also further navigate if it is a manual valve, either carcel open, carcel close. So once you easily understand, okay, these are your instruments and the wall, you can further deep dive and see that what are the control loops available in the my P&ID. So you can see that there will be a sensor element in the field which will be sending electrical signal to your DCS or PLC, and then from there you'll be also again receiving electrical signal back to your walls, control valves or the on-off valve, to either control or isolate your process fluid. Once you can see that simple closed loop control, you can further move and see that what are the safety interlock functions are available within your P&ID. So if you see your square box with a round circle, it will be mostly a basic process control. If you see a box with the diamond, those are the interlocks and the trip signals. To check it further, you can also cross-reference your P&ID with loop drawings and the cause and effect diagrams, where you can easily see that how those particular interlocks are, deployed into the cause and effect diagram and then further implemented into the P&ID. And I will also encourage you to read all the notes, legend, and revision blog. There is always, information about design changes and then a more deep dive into that particular system. Uh, and while doing this review or going to the P&ID, always try to spot the red flags, because nobody is perfect in the world, right? So if you find any missing link or undefined signal or inconsistency in tagging, please feel free to raise the uh, speak up and then communicate it to process, so it will help us to identify any major event before it happens. So this is all, how you can use all this 5 layer of information and then get into the P&ID, try to understand tagging and naming philosophy, line numbering, equipment numbering, and easily interpret P&ID diagram. So just a quick recap. So what we have learned in this entire session, so we understood what is PFD, what is P&ID, and what are the different major difference between the PFD and P&ID, and how we can leverage both the document to gain more insight and understanding about the our process and plant. The importance of the P&ID, how it plays a very essential and key role in operation, maintenance, as well as troubleshooting and training. We have also learned about the layer of information available in the P&ID, how to navigate that information, how to interpret that information, and how to leverage that information to understand more deep about the process. We have also touched on key elements, naming, legends, and symbols in the P&ID diagrams. And at the last, what we have covered is how to effectively read the P&ID diagrams. I'm sure that this all information will help you, to understand P&ID very quickly. And before I conclude this session, remember, reading a P&ID isn't about memorizing symbol. It's about developing engineering vision. Every line, wall, and text tells a story: why it exists, how it operates, and what could happen if it fails. The more you engage with the P&ID, the more clearly you will begin to see the plant on paper, and that's the mark of true engineer, one who connects design with operation and logic with safety. So thank you for your attention, and I encourage you to keep exploring your plant's P&ID. Every time you do, you will discover something new. If you found this session helpful, useful, don't forget to subscribe and stay tuned. More insightful engineering topics are on the way, and I'm looking forward to share with you all. Thank you so much.